Okay, so if we're trying to determine the length of an arc, that means part of the circumference of a circle. So I'm just going to outline the arc length that I'm trying to find here. For some reason, the letter that's used for arc length is S, and I do not know the reason behind that, but that is what is usually used. So I will use that just to be consistent in case on the Regents they were using S and you needed to know what that letter meant. So to set this up, I'm going to set up some ratios. We have this angle measure here. This is called a central angle because it's touching the center of the circle. The center of the circle is the vertex of this 80-degree angle. So my ratio involves this 80-degree angle over the entire angle measure if I went all the way around the circle. Now that entire angle measure would be 360 degrees. If I start at this point and I went all the way around back to my starting point, that would be 360 degrees. So this is the first ratio, is just the angle measure of the central angle, 80 over 360. It will always be over 360. The other side of my ratio involves the arc length. In this example, I'm looking for the arc length. So S is going to be the numerator, and it's over the circumference. The circumference we know is 2 pi r, and the radius here that we're given is 15. So this is just my general setup for this equation. Again, two ratios that are equal. Both ratios are part over whole. In this case, the part is that central angle measure. In this case, on the right side of my equation, the part is the arc length. And then the whole, the denominator, is 360 degrees, or the circumference, the length all the way around the circle. So from here, I just have to cross multiply. So when I cross multiply 80 times 2 times pi times 15, I'm just going to type all of that in my calculator at once. And I need to keep several decimal places when I do this. So in the calculator, when I type 80 times 2 times pi times 15, I get 7,539.8223686. That is all equal to 360 times S, which is just 360 S. Now I'm trying to isolate S, so my last step is just to divide both sides by 360. So make sure that you're keeping these several decimal places here. Type all of that in, divide by 360. Here the 360s cancel out from the right side, so only S remains. And the answer that I should get is 20.94395. And let's round to the nearest tenth in this example. So that would mean that 20.9 is equal to the arc length. Now I want to go back and check and make sure that that seems reasonable. So here the radius, this length here is 15. So if the arc length is 20.9, yeah, that looks right. This arc length should be a little bit longer than the radius, just looking at the picture. If you're drawing a picture yourself, you want to try and make the angle that you create as close to the actual angle as you can so that you can use that visualization to check your work.